Okay, what if an AI could actually get smarter while it's working on a brand new problem? I'm not talking about studying more data, but actually thinking, trying things out, and learning from its own mistakes, right there on the spot. So how is that even possible? Well, let's break it down.
This is really the core question we're digging into today. You see, most AI gets better through this massive training process with tons and tons of feedback. But what happens when that feedback just isn't there? When the answer key is gone? Can an AI really teach itself how to solve something it has never, ever seen before?
So to really get why this is such a huge deal, we've got to first look at a fundamental problem that modern AI is up against.
Okay, so traditionally, AIs learn through something called reinforcement learning. The best way to think about it is like you're studying for a huge test, but you have the complete answer key, right? The model tries something, it gets a score or a correction, and then it adjusts. Simple enough. But what happens when it's actually test time? The answer key is gone. How in the world can it possibly know if it's on the right track, let alone figure out a better way to solve the problem?
And this is exactly where a really fascinating new framework comes into play. It's called Test Time Recursive Thinking, or TRT for short.
So what exactly is TRT? Well, to put it simply, it's a method that lets a language model try to solve a problem over and over and over again. And with every single attempt, it gets smarter based on what it did before. Now here's the kicker. It does this without any external feedback. The whole learning process is completely self-contained. Here's a good way to think about it. Imagine you're working on one of those really tough Sudoku puzzles. You pencil in a number, but then you realize, wait, that's going to create a conflict 3 boxes over. So you erase it and you make a little mental note. Okay, a 7 definitely can't go there. TRT essentially gives an AI that same ability to reflect on its own moves and get smarter for the next one.
All right, so how does this thing actually work under the hood? It all comes down to a surprisingly elegant 3-step loop.
Yeah. At its core, TRT is just this continuous loop of thinking. First, the model basically brainstorms a bunch of potential solutions. Then, it plays judge and jury, picking the one it thinks is the most promising. And finally, and this is the important part, it reflects on all its attempts, especially the failures, to learn something valuable for the next round. So let's break down each of those steps.
Okay, so step 1 is generate. Here, the model just comes up with a whole bunch of different potential answers, what the researchers call rollouts. You can just think of it as brainstorming. Then you've got step 2, select. It looks at all those brainstormed ideas and picks the one it thinks is the best. But really, the absolute magic happens in step 3, reflect. It doesn't just toss the bad ideas in the trash, no. It compares them to the best one and asks itself, okay, why was this one better? And what specifically went wrong with all the others? The answers to those questions? They become a list of powerful lessons that it carries into the very next attempt.
So this all sounds great in theory, but here's the million-dollar question. Does it actually work? Can a machine really learn this way out in the wild? Well, let's take a look at the results.
First up, the researchers decided to set TRT loose on problems from the American Invitational Mathematics Examination, or AIME. And let me tell you, these are not your average math problems. We're talking seriously tough, multi-step reasoning puzzles.
And just look at this. This chart is incredible. It tracks the model's accuracy over 64 rounds of thinking. Just watch how that green line, the TRT model, just steadily climbs higher and higher with each round. This isn't random. It is literally getting smarter and learning how to solve these super difficult math problems in real time right before our eyes.
And the final result after all that thinking? A perfect score, 100%. Using TRT, an open-source model achieved 100% accuracy on this difficult AIME problem set. And that's a first. Why does this matter? Because it shows an AI can tackle problems that need real creativity and logic, not just pattern matching, by teaching itself on the fly.
Okay, so math problems, they have a clear right answer. But what about something messier? Something more open-ended, like writing computer code, where there are literally countless ways to solve a single problem. Well, the researchers decided to test TRT on one of the absolute hardest coding benchmarks out there.
And what do you know? We see that same beautiful, steady climb all over again. The green line here, that's our TRT model, and it shows a consistent improvement in passing the test cases, round after round. It's just amazing. Even in the incredibly complex world of coding, the model was able to generate solutions, judge them, and learn from its own mistakes to write better, more effective code with each try.
I mean, the numbers really do speak for themselves. The models saw these huge accuracy boosts. We're talking over 10 and nearly 15 percentage points. These are just massive gains. And remember, they were achieved entirely through self-reflection at test time, with zero extra training data and zero human feedback. That's the crazy part.
But here's where it gets really interesting. The truly fascinating part is how it's learning so effectively. It turns out the secret isn't just about finding the right answer. It's about deeply understanding the wrong ones.
So, the researchers discovered this really key insight. Check this out. On the left, you can see that the models that focused on learning the don'ts, specific things to avoid from past failures, they performed way better than the ones that just tried to remember the do's or what worked before. The real secret to getting smarter was building this rich, detailed library of failures. And if you look at the chart on the right, you can see exactly the kinds of failures it was learning from.
And this really shows you the depth of the learning that's happening. The AI isn't just fixing simple typos here. No, it's identifying high-level concepts. The biggest categories of lessons it learned were about performance issues, writing slow, inefficient code, and how to handle tricky edge cases. It's basically learning to think like a seasoned programmer, anticipating problems before they even happen.
So, let's wrap this up. What's the big takeaway? Well, it's that this idea of recursive self-improvement is a genuinely powerful new way of thinking about AI. By creating this simple loop of exploring options, judging them, and reflecting on its failures, an AI can get these incredible performance boosts all by itself. And the real secret sauce? It's that learning what not to do is so much more powerful than just trying to remember what worked.
And all of this leaves us with a pretty profound final thought. Think about it. We just saw an AI teach itself to solve world-class math and coding problems, basically from a cold start. So if it can learn this much from its own mistakes on a single problem, what happens when we point this kind of thinking at some of our biggest challenges, like scientific discovery or creating new medicines? The game is absolutely changing right before our very eyes.